Ready? So, today's lesson is on linear factorization. It is working backwards, meaning that you're given the zero, you don't have to find the zeros. And then if I give you the zeros, can you then write the equation that goes with it? So going backwards sort of idea. So, the start is the fundamental theorem of algebra. We talked about this yesterday. So if a polynomial has a degree of n, whatever number n is, and n obviously has to be greater than or equal to 1, or it's not a polynomial, then what? Has how many zeros? So, some combination, right? But if you know the degree, don't want me to call you out, right? In the video for all time. It'll go out there, I'm serious. So if I see you're talking across the table, you're not listening to me, I call you out. It's forever. Do you know the internet? Forever. And like I said, I'm over 300 subscribers. So, I mean, that's a chunk of the world right there. So, oh, there you go. Exactly. Oh, that matters too, right? So, at its most basic, the fundamental theorem of algebra, the degree tells you how many zeros, right? And they can be complex, irrational, or rational to find them. And if there's a multiplicity, it counts as whatever the number of the multiplicity. They each count as a separate zero. So, if C is a complex zero of a polynomial, and in this sense, complex could mean real or could mean imaginary both, is this concept of A plus BI, then x subtract c is a linear factor. So in other words, and we know this already intuitively, that if you know a zero, could you write the factor that goes with it? So if you know the zero, can you write a linear factor of the equation? Can you work backwards? So this means that all polynomial functions can be completely factored. Now when we factor it in this sense, they're not going to be integers in the parentheses. If they're rational zeros, they might look like integers, right? But if they're irrational, you might have the square root of 2 or the square root of 5. You might have 2i and 5i. Like it might not look like what you're used to for linear factors because there'll be irrational numbers and imaginary numbers that could be in the parentheses. Okay, so we're going to start with the function you're given, and then when we practice this, you're going to get a packet, and the second part is you're given the zeros and you have to work backwards from it. So here you have a function, but I don't know how to factor it. So my first thought in number one is it's a trinomial. So to factor a trinomial, if you must, negative 25 and negative 24. Are there two numbers that match that multiply to negative 25 and add to negative 24? So that's step one. It's a simple trinomial, so right away I can write down the numbers I see. X squared subtract 25 and x squared plus 1. Now I'm going to tell you again, my goal is to find the zeros and then use the zeros to factor it completely. So x squared subtract 25 is a difference of squares. So that's x plus 5 and x minus 5. X squared plus 1 is not a difference of squares because you're adding. So I'm going to leave that alone right now. So far, I've done pretty good at factoring. On the side, I'm going to take x squared plus 1, and I'm going to make it equal to 0. Do you already have a sense, because we've done enough of these, that you know what type of answer that's going to produce? So x squared plus 1, when I subtract 1 and take the square root, the answer is going to be positive or negative, and the square root of a negative is imaginary, and the square root of 1 is 1, but do I need the 1 there with the I? Right? So, if I want to write this completely factored, I then would write, and we want to write it as linear factors. What does that mean? What would the degree be on x if it's linear? It would just be x to the 1, right? So, if it's completely factored in this sense, would you have an exponent other than 1 on the x? So if you have x squared, it's not completely factored yet. You have to go further. Then, once you actually have them all as linear, so now, do you see the two zeros, the imaginary ones? We know that they're inverses, right? In this sense, you could even think of it as opposites. So positive I will lead to negative I, and negative I will lead to positive I. This is now completely factored out, and all factors are linear. What does that mean? The exponent on x for each one is 1. All right, good morning, ladies. Soon someone from the Williams Act is going to come in the room, and they're going to ask, do you have the Math 2 textbook and the Math 3 textbook? Okay? So just be warned by that. The second part of the question was, can you now tell me the zeros? And what would you tell me the zeros are? Positive and negative 5, positive and negative I. How does that feel? Like we're reviewing again, right? We're just adding one more element to it, but we're going back and practicing and practicing. That's it. Can you write it as linear factors, where all of it is linear? And can you tell me all the zeros? And again, the degree is 4, and how many zeros did we find? 4. All right, number 2. Do you see a trinomial again? Can I encourage you, because it's simple, that you can do some mental math here? What two numbers multiply to negative 12? And the same two numbers subtract to 4. And you're just powering your mind, right? Just in your head, can you cycle through the options that multiply to 12? And which one should you stop at? Which two numbers multiply to 12 and subtract to 4? We got this? 6 and 2. And it matters now which one's going to be negative. So because the number is negative 4, the bigger number is going to be negative, right? So it's negative 6 and 2. Now, is this completely factored yet? So we need to make sure they're all linear. So what I'm going to do is, I'm going to take each factor that we do have, they're quadratic factors, I'm going to make them equal to 0 and solve it. Do you already know which one will be real and which one will be imaginary by looking at it? So x squared subtract 6, real or imaginary? The solutions. Real. And so when I do that, it's positive and negative, and the square root of 6 is irrational. That's the best way I can write it. When I solve this, right, you end up with the square root of a negative number. Do you know the square root? And again, it's positive and negative. The square root of a negative number is imaginary. Do you know the square root of 2? So you just write it as that. Now, is it wrong to put the I on the right side? No. Most of the time I see I in the front, so you're not confused to make sure it's not under the square root sign. So when it's in front, it's obvious. It's not under the square root sign. That's why it's usually done that way. So our goal was 2. So our first goal was, can you write down the complete factorization? All linear factors. So we take each 0, and we just change the sign, right? The opposite. But we have to write them separately. And same thing with the imaginary. So now they're all linear factors. And then what's the last step? Now tell me the zeros. And you have it. All right, we're stepping up a notch. There are still some that struggle factoring a trinomial that looks like this. Is this a simple trinomial? No. Can you go 9 times negative 4? And what do you get? And 35. What two numbers multiply to negative 36 and subtract to 35? So then I go back into the function, take out the 35, and I put in 36 and 1. Now we're going to factor by grouping. So when I look at the first two, what do they have in common? What's the biggest number that goes into 9 and 36? and they both have at least how many x's? So it's 9x squared. And then how do I find what's left over in the parentheses? Divide. So 9 divided by 9 leaves me with x squared. 36 divided by 9 leaves me with 4. Look at the next two terms, the last two. What do they have in common? A negative 1. And what's left over is x squared plus 4. If you ever notice when you factor that it looks the same but the signs are different, you can always factor out a negative number to see if the signs can match. These have to match to go further. So we have x squared plus 4, and the other factor is 9x squared take away 1. Do you know that 9x squared take away 1 is a difference of squares? So the square root of 9 and x squared is 3x. The square root of 1 is 1, so it's plus 1 and minus 1. X squared plus 4, do you already know what type of solutions that's going to create when you solve it? X squared plus 4. They're going to be imaginary. So when I solve this, what are you going to do? You're going to subtract 4, correct? And then when I solve it, it's a quadratic, so the answer is positive and negative. The square root of a negative number is imaginary, and the square root of 4 is 2. Do you see I go one step at a time to make sure I don't make a mistake? So when I come back here, what's the function now completely factored as linear factors? So we have x subtract 2i, x plus 2i, 3x plus 1, and 3x minus 1. If I said, hey, tell me all the zeros then, what are all the zeros of the function? All the numbers that make it 0. So we haven't actually solved the first one. 3x plus 1. Do you know what 0 comes from that factor? Can you do the inverse of that factor? So instead of adding 1, we're going to subtract 1 and then divide by 3. And the other one would just be adding instead of subtracting. So it's positive and negative 1/3. And the other one we did solve, which is positive and negative 2i. All right, turn the page. All right, your turn. I want you to factor number 4. I want you to tell me all the zeros. And when you factor it completely, there is no longer any quadratic factors. They're all linear factors. So you try number 4, then I'll do number 4. This would be a good time for William and Zach to come in, but they won't, because it's a good time for them to come in. So I'm asking you to practice. Like I did the first 3 for you because you were sleepy. Now you're warmed up a bit, right? Yeah. When you're ready, you can look up at the screen to see if you did the first step correctly. If you started to create a list, that's a really long way to get to the answer we need to, okay? So what did I do is a difference of squares. Keep going. They're both quadratic factors. Try to do the next step, and then when you're ready, look up on the screen. And if you're not writing down anything, it means you're done. All linear factors, all zeros. And you're waiting. Did you do the next step correctly? Did Did you know one of the quadratic factors is a difference of squares again? The other quadratic factor is going to lead to imaginary solutions. So the answer is positive and negative. It's imaginary, and the square root of 9 is 3. So my goal was write it out as linear factors. This is called linear factorization. So one is going to be subtracting 3i, the other is going to be adding 3i. One is adding 3, one is subtracting 3. And then can you tell me the zeros? So are you able to write it as only linear factors and tell me all the zeros? How easy will tomorrow's quiz be, right? Number 5. So start number 5. If I see 4 terms, I'm first going to look to see if I can factor by grouping. And if it doesn't work, I'll have to create a list. But first I'm going to try it. Do you know the biggest number that goes into 16 and 80? I know it's a big number. 16 and 80, the biggest number. And it is 16. And 16 goes into 80 5 times. And what did you notice? They share the same factor. So you can factor by grouping. All right, continue. So we have x subtract 5, x squared plus 16. Take the quadratic factor, x squared plus 16, make it equal to 0, find the solutions. Do you know that when you take the square root of a negative number, of course, it's imaginary, and the square root of 16 is 4. So now I can do the complete linear factorization. One's going to be adding, one's going to... The order does not matter. Which one you put first, subtracting or adding. And then the zeros are positive 5 and positive and negative 4i. Try number 6. You are on a roll, Paw Patrol. Have you watched that show? No? All right, good. Now they're like power pups or something. I don't know. They're like superhero puppies. Yeah, you've not seen the latest Paw Patrol? Yeah, they're now like, I think they're called Power Pups, or something that sounds like Power Pup. Super Power Pups? I don't know. You got to sell merchandise. Can't just have the same old, rubble on the double. Now you got to make them into like a superhero. Now you got to buy some mouse, right? That looks like a superhero dog. Number 6. Maybe one day you'll work for Nick Jr. or Disney Jr. in some evil room that says, how can we get parents to buy more stuff? And they'll talk about it in the room, right? Can only hope to live in the dream. So what should you do first? We have 4 terms. You should at least try. Can you factor by grouping? And if I try, I'll try with you. X squared, x plus 6, negative 2, 7x plus 8. What's wrong? They don't. So can you factor by grouping? So what do we have to do, unfortunately, is the rational zero theorem. So the good news is I only have to look at the caboose there at the end. What are all the numbers that go into 16 evenly? We'll write them down. Be careful that there's no zeros. There's no missing power. There's not. So right away I know positive 1 doesn't work because it doesn't add up to 0. So now you have to go treasure hunting. And if something doesn't work, you just erase and go again. If it doesn't work, you erase and go again. And as soon as you know the remainder's not 0, you don't have to go to the end. Like it's obvious the remainder's not 0, done, next number. And what's unfair is I already know what the treasure is. Unfair. But you don't. And if you ever get to a point where I'm not doing much in the video, do you know what you can do because it's a video? Oh, that's right, you can fast forward. And if I ever go too fast, what can you do on a video? Pause. I know, right? Welcome to the year 2019. Are you giving up on finding the treasure? Never give up. Do we get the treasure? Nice. So -8 was the treasure. I know, it's not nice. Because you probably went through 1, 2, 4, and then whatever, right? Like it took a while to get to -8. That'd be called life, right? Not always fair. So it's -8. What's left over is x squared subtract 2x plus 2 equals 0. It feels like when someone asks for help after school, can I congratulate two that came after school for a long time, got help, figured out their struggles, right, through all of it, right? Can I do that? Like the world can hear, right? I know. You ready? That Nancy and Kaylin, right? They came after school, right, and worked through everything, right, and got there. Didn't give up. All right. Do you know how I'm going to solve this? I can't solve it by factoring. Apparently all of you love the quadratic formula and don't like completing the square. Is that right? No? Some people are okay with both? I've seen more quadratic formula than completing the square. I'm going to complete the square. It's simple, an even number, and do you know how quick it could be? And you know what the good news was with completing the square? Is you don't have to simplify it at the end. It's already simplified, the answer. I don't have to see and divide and figure out how to simplify a big fraction at the end. So, I subtract 2. If you can do that in your head, that's great, but you're taking -2 divided by 2 and squaring it. So -2 divided by 2 is -1, and it's equal to 1. Come on in. I'm going to pause the video, and we're going to pick this up. Good morning. That's okay.